Have you ever looked up at the night sky and just wondered, how did all of that get there? I mean, these enormous, sprawling cities of stars we call galaxies, well, they aren't just born, you know. They grow, they clash, they evolve over billions and billions of years. And today, we're going to try to piece together their incredible life stories.
But okay, right off the bat, we have a huge problem. A single galaxy takes longer to evolve than our entire planet has even existed. So it's not like we could just set up a camera and wait. So how in the world can we witness a process that unfolds on a timescale that's just completely unimaginable?
Well, the solution is, honestly, one of the most mind-bendingly cool concepts in all of science. You see, because light has a speed limit, looking far, far away is looking back in time. Think about it. The light from a galaxy that's 1 billion light years away has been traveling for 1 billion years just to reach us. We're not seeing it as it is today. We're seeing it as it was 1 billion years ago.
And that, right there, makes telescopes like Hubble and the James Webb Space Telescope our very own time machines. By capturing this ancient light, we get to see galaxies at every single stage of their lives. We can see a teenage galaxy over here, a little toddler galaxy way, way over there, and by doing this, we can actually piece together the entire story of how they grow up.
Okay, but when we use our time machine to look through this cosmic photo album, a central mystery just leaps right out. It turns out galaxies come in this stunning variety of shapes and sizes. And understanding why, well, that's the key to their entire life story.
So on one hand, you've got these elegant spiral galaxies, kind of like our own Milky Way, right? These beautiful, flat, spinning disks just full of gas and dust and bright young stars. But then you have the ellipticals, and these are massive, reddish, kind of three-dimensional blobs of older stars with almost no gas or any new star formation happening at all.
So what gives? Why does one giant cloud of gas grow up to be this majestic, swirling spiral, while another one just becomes this giant, featureless elliptical? To figure this out, we're going to have to become cosmic detectives and start following the clues.
So our first clue, it comes down to that classic debate, nature versus nurture. In this case, nature is all about the initial conditions a galaxy is born from, the basic properties of that very first cloud of gas and dust.
And it seems to boil down to two really simple starting conditions. So if a protogalactic cloud had a whole lot of initial spin, then as it collapsed, the gas would just naturally flatten into a disk. Boom, the perfect recipe for a spiral. But if a cloud was super, super dense to begin with, it might have formed stars so quickly that all the gas got used up before a disk ever had time to form. And that would create an elliptical galaxy right from the get-go.
But here's the thing. Nature is only half the story. The nurture a galaxy gets, the environment it grows up in, plays a massive role. And let me tell you, the early universe was not a peaceful place. It was crowded, it was chaotic, and it was unbelievably violent. When we look deep into the past with our telescopes, a lot of the youngest galaxies they look completely mangled, like they've been in a cosmic car wreck. And that's because they were all packed so much closer together than they are today. And when you squeeze a bunch of massive things together in space, gravity pretty much guarantees they're going to crash.
We've actually run computer simulations that show us exactly what happens when two spiral galaxies collide. Their immense gravity literally tears apart those beautiful disks. Gas clouds just slam into each other, which triggers this furious burst of star formation that burns through all their fuel. And over millions of years, they merge into a single, much larger, and way more disordered elliptical galaxy.
So we have the birth conditions, nature, and we have cosmic collisions, nurture. But there's a third, final piece to this whole puzzle, a hidden engine of almost unimaginable power that's lurking at the very heart of these galaxies.
See, in the early universe, a lot of galactic centers were just blazingly bright. We call them active galactic nuclei, or AGN for short. The brightest ones, called quasars, could actually outshine their entire host galaxy of billions of stars. And we now know that all of this incredible energy is coming from matter being superheated as it spirals into a supermassive black hole. And when we say supermassive, the scale is it's staggering. Take the black hole at the center of the galaxy M87. It has a mass of 6 billion suns. That is a concentration of gravity and power that is almost impossible to really wrap your head around.
And here's the kicker. These black holes are not just sitting there passively. No way. They are active engines. They launch these colossal jets of plasma at nearly the speed of light that can stretch for hundreds of thousands of light years out into space. And by heating or just straight up blowing away all the gas, they can effectively shut down star formation across the entire galaxy. They can profoundly shape its whole destiny.
Okay, we've gathered our clues. We have the initial conditions, we have the violent collisions, and we have the monsters hiding in the middle. It's time to put it all together and deliver the verdict on why galaxies look the way they do.
And the verdict is, there isn't one single answer. A galaxy's final shape is a complex recipe that has 3 key ingredients: its birth conditions, its nature, its history of cosmic collisions, its nurture, and the powerful influence of its own central supermassive black hole.
And here is where it all gets really personal, because astronomers have discovered that nearly all large galaxies nearby, and yes, that includes our own Milky Way, have a dormant, sleeping supermassive black hole at their center. This is a huge clue. It tells us that most galaxies probably went through a really violent, quasar-like youth before they finally settled down.
Which leaves us with one final, kind of a chilling question. We look out at a universe today that seems relatively calm and ordered. But if almost every single galaxy we see, including our own, contains one of these sleeping giants, it means the entire cosmos is just filled with this incredible dormant power. And it really makes you wonder, what would it take to awaken the monster at the heart of our own galaxy?